So in this part that is going to be, at least for now, the last part of the using your own splash screen tutorial, I'm going to show you how to create the header file for which we already seen the patch that we replaced when we looked at our psplash tutorial. And this is like an example of the image that was generated for us and like for the patch, in addition to the background color that we repainted. And we're going to see how to actually generate this header file and add it to our own recipe in the meta pscg layer, and then replace in the right way, in the proper way, the splash screen of our tutorial Yocto project instance. So let's do this. So I'm now getting you back to the folder where we did our Linux-based tutorial. Let me just remind you, we had an autoconf script and we did several things, and the steps were as follows. We cloned just like the Yocto project, we checked out a specific revision, and then I applied a patch that did essentially modified the background color and removed the other H files that was auto-generated and generated another one. So how was it generated? So actually what I'm going to do now, and I don't promise it will be like in a good resolution or looks nice or something like this, I'm going to do it live and super quick to show the quick way to do it without being the best graphical designer in the world. I'm going now to go ahead and just take a PNG image and copy it into our directory. Okay, so the image that I'm going to be using will be this one. So this is a raw image that is actually a transparent PNG. Okay, it's pretty big, so if I just show this one as is, I will most probably get it cut. So I will do some trivial manipulation and whatever happens, happens. Okay, so this is what I'm going to show. So first, let's go back to our source code. And in the source code, we actually have a script that was given for us, which is called make image header. Make image header does the following thing. It's a script that uses GDK pixbuff csource that you will need to install. It actually is available in your Yocto distro, but if you want to just do it like locally, like I do now, you need to install the relevant package. And it receives a file name and generates an output file name that has the same name, but takes away the PNG suffix and then appends to it -img.h. So that's what it's going to do. And what we're going to do now is actually go ahead and generate an example of this one. Okay, so the first thing we are going to generate now is we'll generate a header file for existing images under base images. Let's see what is available under base images. We already saw that. So there are these two logos. And let's just go ahead and use the make image header sh with the file name. So let's choose either one of them at random, and pay attention what else I give. I give it another parameter, and the parameter is used for the sed close that we see here. So we take the second parameter, like the name, and then we append to it underscore img, and we substitute things in the file. Okay, so that's what we're going to do. So have a look. So what we do here at the file, it's a template file that is being used by the GDK Pixbuff application. So what we do now is this. I'm going to give it pokey. There is a reason for this. And at the end of this script, we're going to have an output file name, pokey logo image.h. Why? Because the base name of the file was pokey logo, and we take away the suffix and we append to it .img. Now what happens in this file, and where does this pokey parameter comes in? What happens is this, that we have here some defines that are being set according to the characteristic of the image, and this is going to be the RGB map and coding of it. Now, if I didn't give it pokey here, then I will have compilation errors because the framework expects this file. So if I go ahead and just use this as is, then I'm good enough to go with the splash screen. Okay, I will not show you how I generate the Linux splash screen now because in this recorder software it will not capture dev fp0. I will show you the final result. Okay, so I've done that and everything is good and everything is nice. Now I'm going, just for the sake of simplicity, I'm going to go ahead and copy from the image that I wanted to look at. I'm going to copy it also to base images, although the folder itself doesn't really matter. And now I'm going to do the exact same thing, make image headers on base images pscg logo, and the result is going to be, after I give it the pokey parameter, it's going to be this one. Now let's, just for fun, let's look at the sizes of what we generated. So we can see that the pokey logo image is by 2 orders of magnitude smaller than the image that I generated. Okay, look what I have here. Like the generation after the PNG is here 3 megs. Okay, so I can go ahead, I can use it, and I will see it like probably very spread out unless my resolution is very big. And I can go ahead and either use GIMP, or I can use something like ImageMagick or any other editor they have. With ImageMagick it's going to be like much simpler in order to downsample this file. So that's what I'm going to do. I'm not going to put too much effort into it. So of course I work on the image itself, sorry. So it will open ImageMagick, and look how big the image is. Okay, this is why I will most probably not see like all of it. So I'm going to go ahead, let's see the menu in a place that is comfortable, view, and I'm just going to do now half size once. I'm going to do half size twice. Now maybe I downsampled it too much, maybe not. Let's double the size of it. Yeah, and then let's see how it works. Alright, so now I'm going to go ahead, save, and I don't care overriding it. I don't mind overriding it. That's what I'm going to do. So I'll override it, yes. Just for fun, I'm going to now, let me exit this one. Just for fun, I'm going to keep this one. And I'm going to now generate it again. So now I can see that the file is indeed smaller. Now it's 3 times smaller. And obviously, if I look at them, at the files, then they're going to look different, okay? So you have like these resolutions, and this one is like much bigger. So this is the generation of the file itself. So I'll make a long story short, and I will tell you that the file that you really need is going to be the header file that is prefixed with pokey. So let's have a look at what it looks like. We're going to have psplash pokey img. This is the one that I changed, so I'm going to change this one again, okay? Just for fun, I'm going to remove it completely, and I'm going to move this one. I'm going to rename it. So that's going to be my file. Now I can actually go ahead and apply a patch, but I don't really need to. What I'm going to do at the first phase is exactly what the meta pokey layer does when it wants to override when it wants to add in the bb append, when it wants to override the file. So that's exactly what I'm going to do. So just reminding you, before on my host, when I ran run QEMU, then I was in this directory, QEMU-x86, which is the build directory that I had actually. And actually, so this was when I ran like the original Sato, if I ran the original Sato. And when I want to go and replace with my own image, then what I'm going to be doing is I will create a layer of my own. So this is how my folder looks before, okay? And I just want to tell you one thing, and I will like fix it soon enough. What we did in one of the first videos that we did, we overridden the pokey recipe. So this was what we modified before, and those of you remember like the value of the file, then it started with 905317 and so on, okay? So in our results, our solution, after we add the layer, we want to ensure that we don't have this one, okay? Now let's go ahead and populate the layer. So I'm going to get back. I'm going to go to QEMU-x86, and what I'm going to go and do is add here a layer. And add it to the conf local conf file. And add it to the conf bb layers conf file. So I'm going to go here, add another line. The other line is going to be top dir slash meta pscg, and very important not to forget this. Now I will pause and copy something that I already have populated, and then I will show you how the recipes look like. So after we populated meta pscg, we see that we have under recipes core psplash. So we can see that what we have here are two things. First is the bb append file that we can see that has file extra path. Prepend, that means that we prepare to the file extra path as we mentioned. And pokey is an override, which means that if it's in the list of overrides, and it is in the overrides of distros, just like there is an override of machine and so on. We can talk about overrides in another session. Then we're going to add this dir files, which is the second thing here, the second directory, into the list where we're going to search for files in this recipe. So every time we have, like, on the original recipe, let's say src URI equals file and then whatever, then we're going to search over here. Okay, I'm going to, of course, undo it. So we don't need the prepend to poky. It's for this, we can leave it, but just for the sake of demonstration, if you explore the concept of override, we can just do the prepend. The important thing is that we search here before we search in other places. And this will be useful because we're going to make sure that the priority of our layer is higher than the priority of the meta poky layer. Okay, so that's the first thing that we have here. And the second thing what we're going to do is we're going to populate the files directory. We're going to make sure that we put here so it's another terminal, but it's okay. This was the folder that we worked in, where we generated the output of pokylogo image.h ourselves. Okay, and what we're going to do is we're going to copy this one into the files. So that's what we're going to do. So I'm going to copy this into this directory, and I'm going to make sure that the MD5 of this, whatever we copied, is 5AD8 and so on. So now that we have the recipe, we're going to go ahead and build poky. Okay, one last thing that we need to take into consideration is that we need that our priority will be higher than the default poky, which was 5. So we'll set it back to 6 or 9, like it was in the initial demo. So after we created our layer, we will go ahead to the build here and rebuild the image. So now we can see that we are doing the do configure before we patched, which is pretty much exactly what we did before. You could see the different phases. Here, do fetch is tainted because I invalidated the timestamp for it when I wanted to show you how to make sure that the source that you see in Git after you check out is up to date. And now we're going to do rootfs here. The computer I'm recording on is not as strong as what I have in Amazon, so it's going to be less fast. But at the end of it, we'll be able to run the core image Sato with run QEMU and see our changes. Now I remind you that in these particular changes, what we did was we just replaced the header file. Okay? So after that, I will show you how to also create a patch that will also replace the background that does actual patching to the code. Okay, you can see when the computer is slow the different phases, like we had do image ext4 and then do image star, which is exactly what we covered under the deploy dir. The image is the root file system. Do image complete is the rest of the deploy directory, and now we're done. Okay, so now I'm going to go and run QEMU with KVM and look at this. Look what happened here. I stopped it deliberately because of our previous video. We see home run tutorial QEMU-x8664, which means that we have the deployed here. Okay, we saw it in the previous video. So I'm just going to unset it, and then these are like the little things that you need to be aware of. Oops, typo. So this is why I do it on purpose, so that you are aware of. And then I'll do run QEMU again, and now we will see that the image runs from where we expect it to run. Okay, little nuances that are important. Here it is, our splash screen. Okay, so we did it, and just to show that this is like the image that we have here, so we can also go ahead and do all kind of things, and that's it. Okay, so this was our splash screen, and now I'm going to show you two things. Actually, I already showed that even if we build for the core image minimal, then I will still see the splash screen. So I will just show you how to create a patch that adjusts it, okay? And it adjusts the background, and we'll end it with this. So we already have the solution for it pretty much from the work that we already did, but I already have the file that I put under files. I do not want to patch it. What I want to patch is the source. I do not want to replace the source file, but I'd rather want to just apply a diff, apply a patch for it, which is this one. So look what I'm going to do. I'm going to revert the changes that we had here. So let's do git checkout of this file. And I'm going to go ahead and see that this is good enough for me. Now, let's be honest with you. We can go do now git diff and then redirect it, and that's it. We can put this file in the files directory as a .patch file, very important. But what we're going to do is we'll do it the proper way. I'm going to git checkout -b setting background to green. That's what I'll do. I will add psplash color.h, which is a file where you can control all kind of things. You can control like the bar colors and so on, but I just wanted the background. And I will do git commit -m, adding a green background. Green is nicer than white, gray. Okay, now this commit has a slash in it, so like for the name that's going to happen when we're going to do git format patch current commit, the difference from it to the previous one, it's going to be trimmed. Okay, and if the length is too long, then it's going to be trimmed anyway. And what we're going to do is take this guy and copy it to our recipe. Okay, so what I'm going to do now is go to the recipe again, and what we had prior to it in a psplash git bb append is we append the files as a place where we want to search for files. So I'm going to copy the patch that we generated into the files directory, and I'm going to tell the build system that this is going to be a source file. How do I do it? I'm simply going to add to src URI. I'm adding to it, I'm not overriding. File and our file here. So once I've done that, I can go ahead and build again. That was a typo. Let's also get back. It doesn't really matter, but let's also get back to the build directory. So bitbake core image sato. Now it's going to build it. And now we will run QEMU again. And we expect to see green background because of the patch that we put. So there it is. And there is our progress bar. This is poor design. We should have also probably replaced the colors here, but we are embedded engineers. We are not designers, at least not now. And I forgot to provide the KVM parameter. This is why it's so slow. Okay. Otherwise, it would be much faster. See, ta 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 ta. Boom. All right. So that's what we have. So let's see a proof over the code that we actually got what we wanted to get. So I actually went here and I just wanted to make sure that, pay attention, like we get to the current, it's the same revision all the time. So what we have here is the patch file that we added in the src URI, right? This is it. That's the patch. And we also have the image that, if you remember the MD5 sum, it starts with 5AD. And the source itself is going to be unpacked over Git, where the current state, if we look at the diff, it actually looks pretty much the same as what we had when we just generated it ourselves, right? In the other directory of psplash when we generated it. But the reason for it is actually double, like things look a little bit different right now. So if you look like at the log, none of my commits is there because I added just a patch, okay? And I can see that the header file has been generated, right? It's here also, it's the same hash. And the other thing that I can see is that psplash colors does the green trick here. So this ends our tutorial of replacing the splash screen. And if it interests anyone, I can go and actually teach a little bit, explain a little bit on the source itself. That is how things are being done, what are like the manipulations. So long story short, long story very short actually, then you would want to see what IO controls are being called and to who. And you can see like the get screen info. This is like Framebuffer, and you can go ahead and see that like you get mode, and you can see that you write all kind of things into the console. And if it interests anyone, I can go and cover it more. Okay, it's pretty easy actually, and it explains a lot about very simple computer graphics, and definitely explains why, speaking of like the BSP, if core image SATO and core image minimal are the same, then it's just about like the user space that writes into it. Okay, so that's what this does. If you are also interested, then we can go ahead and you can see that like the main function is going to do polling. This is actually interesting on a pipe FD and looking for instructions. So the instructions, I'm not showing it like too much. The instructions are going to be here. And here we have all kind of arguments, and then we're going to go over a loop. But the instructions that we're going to be looking for are going to be like drawing instructions or like exit instructions and so on. And you are welcome to go ahead and explore it yourself. It's really not that difficult. So having said that, this is going to be the end of the current video. And well, if anybody wants to ask something, please feel free to reach out. I just did it, like live and nice, and there are some unintended typos sometimes and so on, but it's not pre-recorded really. I mean, I just post every now and then, and that's like a flow of doing it like right now. It's an easy flow once you're experienced with it, but if you're not, then I hope you learned a thing or two.